For blood test number 5 in 2025, when using Dr. Morgan Levine's biological age calculator, PhenoAge, we saw that my biological age was 16 and a half years younger than the chronological. So what might be contributing to these data? Let's start off with prescription meds. And for those who don't know, I was diagnosed with hypothyroidism in my 20s, so I've been taking thyroid hormone medication every day since then. More specifically, the recent dose is 75 micrograms per day of levothyroxine and 20 micrograms per day of cytomel. But why these specific doses? Well, the goal is to get my free T3 levels to greater than or equal to 3.3 picograms per mil, which then raises the question, what's optimal for FT3 or free T3? So part of that story is here. This is survival or all-cause mortality risk of death for all causes on the y-axis, plotted against years after the initial assessment of FT3 levels, who was alive and who had died up to 12 years later. And what we can see is that the best survival was associated with free T3 levels in the 3.3 to 4.2 picogram per mil range. In contrast, those that had FT3 levels that were 2.3 to 2.8 picograms per mil, they had the lowest survival or worst survival. Now, prior to this thyroid hormone medication shift or recent shift, most of my data was in that yellow curve. So it's only recently that I've been able to get my FT3 to around 3.2 picograms per mil or greater. But this is only half of the story for FT3. How does it change during aging? And if you want to see those data, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers. So these aren't the reference ranges. This is what may be optimal for health and potentially longevity based on 48 published references, and it currently includes more than 2 hours of video content from those 48 published references. It includes the 33 biomarkers shown here, including FT3 and other thyroid hormones. So if you're interested in that, check it out. All right, so back to our story, and more specifically, what supplements did I take prior to this test? So the first had been or has been a staple for the majority of my 15 years in Boston, and that's vitamin D, as it should be obvious that I couldn't get full body sun exposure for at least 9 months out of the year. So I've been taking vitamin D, or I had been taking 2,000 IUs of vitamin D per day, and more specifically for this test, or prior to this test, which was on July 22nd, I took 2,000 IUs from May 27th through June 20th. But this was only for about half of the period that corresponds to blood test number 5, again on July 22nd. And we can see that 56-day period in between blood tests there. So immediately after test number 4, which was on May 27th, through July 21st, that 56-day period is from test number 4 to test number 5. So I supplemented with vitamin D for about half of that period. So why did I stop? Well, I drove from Boston to Austin, as I now live in Austin, Texas, starting on June 23rd. After I arrived in Austin, I've been able to get full body sun exposure. In fact, in the 2 months that I've been in Austin, I've gotten more days of 20 minutes of full body sun exposure front and back than I got in Boston probably in the past 3 years or 4 years combined. So with that in mind, I've taken vitamin D out, and I'm going to measure circulating levels of vitamin D to see how much of an impact that daily sun exposure, 20 minutes of daily sun exposure, will have on my circulating vitamin D levels without taking supplemental vitamin D. So stay tuned for those data for test number 6. I also supplemented with NMN, nicotinamide mononucleotide, not just for NAD, but also I wanted to test subjectively if I felt a difference, if I felt better on it. And I also took 2,000 to 2,100 milligrams of NMN per day, because I wanted to see if that could improve my sleep quality, which has been a major challenge over the past, few months, and even going back beyond that, where whether it's nighttime awakenings or I can't sleep, a full 7 hours. So I took NMN to see if it could make an impact on that. And for those who are going to say it's a prostate issue, my PSA levels have always been 0.3 or less. That's about 7 tests going back over the last few years. So I don't think it's a prostate issue. But note that I only took NMN from June 5th to June 10th. So that's at least a month before testing on July 22nd with no NAD precursors. And I took out nicotinic acid for this test because nicotinic acid and high-dose niacin, in my case, for whatever reason, is significantly correlated with lower lymphocytes, which is data moving in the wrong direction. So I took no NAD precursors for the 51 of the 56 days that corresponded to this test. So what impact did that have on NAD? So to find out, I've been sending blood to Ginfinity for blood intracellular NAD analysis. And if you want to measure your own blood intracellular levels of NAD, there's a discount link in the video's description. So on the same day as testing all the stuff for Levine's PhenoAge and other biomarkers, I also have NAD data. And on the day of this test, it was 14.8 micromolar, which is the lowest NAD level that I've had in my 3 years of testing. So taking some NAD precursor seems to be essential. So it's not going to be nicotinic acid for now because of lymphocytes. And again, I don't know about causation, but when I took nicotinic acid out, even very low doses, less than 200 milligrams per day, lymphocytes started to increase back closer to optimal levels. Now I'm going to get more insight into that story by looking at CD4 and CD8 levels, because is it possible that maybe 2,000 lymphocytes in my case isn't optimal? Maybe somewhere around 1,500, which is where high dose nicotinic acid, or up to 200 milligrams per day, sends my lymphocytes. Is that optimal based on CD4 and CD8? And if you missed the CD4, CD8 story, or the immune health risk profile, I'll link to that video in the right corner. All right, so I'm also taking a bunch of supplements now for homocysteine, as my data is close to age expected, somewhere in the 10 to 11 micromolar range, and saying something is age expected is dirty words and fighting words for someone like me who's trying to have everything being youthful. So in terms of what I'm taking to try to keep my homocysteine or push my homocysteine lower, that includes a stack of methyl B12, methylfolate, and B6, so 1,000 micrograms, 400 micrograms, and 1.5 milligrams respectively. I took that for 54 of the 56 days that correspond to test number 5, but a very minor impact on homocysteine, if any. Note that historically, that stack, those 3 vitamins, have reduced my homocysteine, or are correlated with about a 10% lower homocysteine. And that might not seem like much, but I'm looking for any advantage I can get, at least through supplements, as diet doesn't seem to make a big dent on my homocysteine. Now, as another part of that story, I've also reduced riboflavin supplementation to closer to physiologic levels. So the RDA for riboflavin is about 1 milligram per day. In terms of getting it in a pure form in a supplement, with no fillers or no added cellulose or silicon dioxide, which is a caking agent, I'm trying to avoid all that and only get the pure supplement. In terms of the pure supplement, I was only able to find 400 milligrams per day, which is a supraphysiological dose, 400x the RDA. The gastrointestinal tract can only absorb about 27 milligrams per day, and I plan on including that data in a future video. So with that in mind, I've slowly increased my riboflavin intake. You can see for this test, it was 6.6 milligrams per day, with the goal of potentially getting it closer to 30 milligrams per day, which is the maximum amount that we can absorb in one sitting. Now, maybe I'll split the dose so I can potentially get up to 60 milligrams per day, but for now, I've got a 6x higher riboflavin intake relative to the RDA. And I did that because riboflavin, or vitamin B2, is a required cofactor for the MTHFR protein, which is a part of the folate cycle, which is involved in potentially lowering homocysteine. So if riboflavin is low, MTHFR activity will be suboptimal, potentially making it harder for methyl B12 and folate to help decrease homocysteine. Now, as another part of the riboflavin story, even if that doesn't help make a dent on lowering homocysteine, I may keep it in anyway at a relatively high dose. And that's because there's published data that cells that have a higher rejuvenation capacity have relatively higher levels of riboflavin. So again, that's a story for another day, but I may keep it long-term in the approach. Similarly, zinc is now in the approach, supplemental zinc. So from diet, I've always gotten close to the RDA, which isn't terribly high, which then raises the question, what's optimal for zinc? So if you saw Dr. Emily Ho's recent presentation and interview on the channel, you know that up to 40 milligrams per day of zinc is recommended by the institute that she's a part of, the Linus Pauling Institute, in part inspired by her lab's research. So with that in mind, I've been supplementing with 15 milligrams of zinc per day, zinc glycinate per day, with the goal of potentially optimizing zinc status. Now, zinc is important, or potentially important, in the homocysteine story because it's a required cofactor for betaine methyltransferase, which uses betaine in combination with homocysteine to reduce homocysteine levels, thereby producing methionine and dimethylglycine. So if zinc status is low, even if betaine levels are high, the conversion or reducing homocysteine in that case will be suboptimal. So to try to minimize that, I've added zinc into the approach. Now here too, this is another one where if I'm not able to reduce homocysteine directly by including zinc, I may keep it in long term as a supplement. As I mentioned, Dr. Emily Ho, as a part of the Linus Pauling Research Institute, they recommend up to 40 milligrams of zinc per day, as it's obviously involved in immunity, but it's also potentially involved in lowering inflammation, at least in aged animals, based on her lab's research. So zinc is another one that may stand alone as a staple in my diet going forward. Now, as another quick note that for those who have followed my journey, that know that I've been almost exclusively very low on supplements for a very long time. As you can see, I'm starting to change that very slowly by adding things in very gradually. And I've done that because I think I'm pretty close to saturated on impacting biomarkers versus by using diet. So with that in mind, I'm considering and I'm open to increasing doses of specific nutrients that may be involved in specific pathways that are potentially suboptimal biomarker-wise in my case. So stay tuned for that story, obviously in future videos. But that's it for supplements. No geoprotectors or senolytics are associated with this 16.5-year younger biological age, which then brings us to diet. What diet composition corresponds to test number 5 in 2025? And that's what we'll see here. This is the average daily dietary intake for that 56-day period that went from test number 4 to the day before test number 5, so May 27th through July 21st of 2025. And note that these aren't estimates that you're looking at here on the table. I weigh all of my food. I then enter that data into a diet tracking app, Cronometer, and if you want to use Cronometer too, there's a discount link in the video's description. And then I pull the Cronometer data into a spreadsheet so that every blood test has a corresponding average dietary intake. And then because I'm tracking diet, I can look at correlations and try to move biomarkers based on following those correlations. All right, so note that this list is ranked in terms of amount in grams from highest intake to lowest intake. So there were 54 different foods that I consumed for this test. And there are 3 exceptions in terms of the ranking by grams. Green tea, which is in ounces, and I drink green tea every day. It's a staple in the approach. It's been a staple in the approach for a very long time. And if you want to use what I use, which is organic loose leaf green tea sourced from Japan, discount link in the video's description. 2 other exceptions to the rank by grams are ice cream and cookies. And these are ranked in calories. This is calories per day for those 2 foods. Now, at this point in the video, I always have to mention, I didn't eat 21 calories of ice cream per day every day, or 14 calories of cookies every day. I didn't do that. This is 2 days of intake and then no other intake for both of those foods for 54 days. So I have to always mention that in the video because someone will make a snarky remark saying, this guy's eating 20 calories of ice cream per day, he's taking 1 bite. No, it's not true. This is 2 days of intake, 54 days. No, I didn't have those foods at all. But more on those 2 foods and others in the cheat meal section of the video. For now, let's focus on experiments. What experiments did I specifically do for test number 5? As the goal is to optimize those weak spots like homocysteine, DHEA sulfate, now cystatin C, and actually HbA1c has started to become a weak spot. So what did I do to try to improve weak spots without messing everything else up? So the first one is obviously homocysteine related. I added beets back into the approach. I had taken them out for a couple of tests, so I added them back in, and I added amaranth, which both of those foods are rich in trimethylglycine or betaine. Now, I say rich, they're rich for trimethylglycine content in foods. But collectively, adding about 150 grams of beets per day and the 7 grams from amaranth, that only adds about 200 milligrams of betaine or trimethylglycine, which clearly didn't make a major dent on homocysteine. So with that in mind, I've added trimethylglycine as a supplement into the approach for test number 6, and I'm currently taking about 1.5 grams per day. In the past, I've taken up to 4 grams per day, and it didn't make a dent on homocysteine, but at that time, I wasn't taking zinc. And if my zinc status is suboptimal, I would expect that betaine methyltransferase activity is suboptimal. So even with very high levels of betaine, that may not lower homocysteine if zinc status is suboptimal, thereby resulting in a lower activity for betaine methyltransferase. So we'll see if that's true coming up for test number 6. I also added broccoli back into the approach. So broccoli has been in and out of the approach for a long time, but just like beets, I took it out of the approach for a couple of tests to see what it would do to the biomarkers. Now, I specifically added it back in for cystatin C. My cystatin C levels after an initial 0.72 milligrams per liter, which is close to optimal, which I define as less than 0.7, have increased every test since. to the most recent test, which was 0.87 milligrams per liter. Now, that's not terribly high, but it's moving in the wrong direction. So I went back and looked at my diet notes and saw that for my best cystatin C data, the diet included beets and broccoli. So for the past 2 tests, I didn't have those foods. So to do the experiment, I added both of those in to see if it could impact cystatin C, and it didn't. So that suggests that something else is going on with respect to why cystatin C is moving in the wrong direction. And that story may revolve around fat, saturated fat intake, which is significantly correlated with higher cystatin C, but again, that's a story for another day. I also increased avocado intake, or added it back into the approach. Avocado too has been in and out of the approach, and I specifically added it back in to test its correlation with lipoprotein A, and that's what we'll see in that plot. On the y-axis, we've got lipoprotein A, and on the x-axis, we've got my average daily avocado intake that corresponds to each blood test. And there, we can see that there's a significant inverse correlation for avocado intake with lipoprotein A. In other words, when my avocado intake has been relatively higher, that's significantly correlated with lower lipoprotein A. And vice versa, when I've had lower avocado intakes or none, that's significantly correlated with higher lipoprotein A. So to test that correlation, I added avocado back into the approach. And for the most recent test, lipoprotein A was still on the higher side, which it has always been, either on the higher side of the reference range or outside of the reference range, 91 nanomolar. I've still included avocado going forward, as it may be a part of the lipoprotein A story. This correlation is still significant after running the correlations following test number 5. What I showed here is after test number 4. So I'll have to figure out another way to try to keep my lipoprotein A on the lower side. Now, the good news in that story is that HSCRP is a part of CVD-related risk that's related to lipoprotein A. My HSCRP is almost always super low, less than 0.3 milligrams per liter, so that's good news in terms of lipoprotein A-associated CVD risk. And also my ApoB is relatively low, less than 70 milligrams per deciliter, even with relatively high lipoprotein A. But I'd still like to have low lipoprotein A within the context of low ApoB, as relatively higher lipoprotein A is more atherogenic than LDL. I also increased coconut butter, approximately doubled coconut butter intake. And I did that to test its inverse correlation with indoxyl sulfate, which is a gut bacteria-derived metabolite. Indoxyl sulfate, or IS, was also inversely correlated with DHEA sulfate. So those two correlations suggested that if I increase coconut butter intake, I might be able to reduce indoxyl sulfate. And if indoxyl sulfate is involved in mechanisms that reduce DHEA sulfate, I may be able to get an increase for DHEA sulfate. So that nice hypothesis based on data didn't work. DHEA sulfate didn't go higher with the 2x higher increase for coconut butter. So I've since cut coconut butter down for that and some other reasons, which I'll go into for the test number 6 diet video coming up in about a month or 2. All right, so I also increased Brazil nut intake from 7 to 11 grams per day. Now that might not seem like a big jump, but for whatever reason, Brazil nut and correspondingly selenium are significantly correlated with lower Candida IgG in my data. Now, Candida IgG for every test going back for about a year and a half has been higher than the reference range, which suggests that my immune system has to work harder than it should by producing immunoglobulins to keep systemic Candida levels in check. Now, I'd prefer to help my immune system by reducing systemic Candida load, thereby reducing Candida IgG. And adding more context to that, systemic levels of total IgG may be important in terms of lifespan. And if you missed that video, I'll link to it in the right corner. I also increased olive intake, and this may not seem like a big jump, but I increased it from 36 to 44 grams per day. For test number 6, my current average daily olive intake is 75 grams per day. And for those who are familiar with the channel, you know that I've been on this olives versus olive oil, the processed food versus the whole food, which is really optimal for health. So for almost all tests, olives have been a rare and very small component of the diet. Olive oil has been an almost never food, as I think all oils are just processed UPF, low quality nutrition. So I'm going to test this hypothesis. If I titrate olives higher, what biomarkers will change? Will any biomarkers change? Or maybe will some biomarkers move in the wrong direction? So we'll have to see going forward. I also added in nutmeg, and note that what you see there is 0.04 grams. This is only maybe 1 or 2 days of eating nutmeg in ground form before test number 5. I took nutmeg out because as I got closer to test number 5, I realized, wow, this is a new addition. I might want to take it out because I don't know what it's going to do to biomarkers. But then it raises the question, why did I add it in the first place? Well, nutmeg contains a metabolite called nectandrin B. And the reason why nectandrin B may be important, because as we can see in this paper's title, it significantly increased the lifespan of fruit flies, or Drosophila, which is what we'll see here. So on the left, we've got lifespan data for male flies and female. On the left, and female flies on the right. On the y-axis, we've got percent survival plotted against time, or lifespan, in days. And then we've got 3 groups: control in black, rapamycin-treated flies in red, and then nectandrin B-treated flies in blue. So first, let's take a look at median survival. This is the time when half of the flies have died and half are still alive. And then we can see by the blue and red shift to the right, it's very minor, insignificant relative to what happened for maximal lifespan, as indicated by 20% survival. This is the time when 80% of the flies have died and only 20% are still alive. And now note that both rapamycin and nectandrin B lead to a significant extension of maximal lifespan. So that's one way to look at the data. The other is that nectandrin B extended lifespan in Drosophila to the same extent that rapamycin did, which is potentially good news for nectandrin B and for nutmeg consumption. Now, this effect wasn't only evident in male flies. The same situation happened in the female flies. So a minor impact on median lifespan is shown by 50% survival. But in terms of maximal survival, once again, look at that rightward shift for both rapamycin and nectandrin B treated flies, which again suggests that nectandrin B may be as good as rapamycin, at least in flies, for extending lifespan. But one study just generally doesn't move the needle for me. I want to know if there are other studies. Is there a broader consensus of research that may suggest including nutmeg and correspondingly nectandrin B may be important for health? In another study, nectandrin B prevented cellular senescence in fibroblasts. Fibroblasts are found in skin, but also connective tissue, so ligaments, tendons, cartilage. So this may be important for those cell types, for those organ systems. So with that in mind, it raises the question, how much nectandrin B and or nutmeg may be optimal? And I don't think anybody knows the answer to that. I don't know the answer to that. So for now, I think including some nutmeg to get nectandrin B rather than none may be important. So with that in mind, expect to see it for the test number 6 diet composition video. Next up are cheat meals. Following every blood test, I include some junk. I do that immediately after blood testing for up to a couple days after, and then I shut it off. I basically get satiated eating the junk, and then I want to eat my normal standard diet for the remaining dietary period until blood testing. Now, I know that there are others in the space that eat literally no junk, and if that works for them, that's great. Historically, when I've done that, it doesn't work long term. It ends up with a binge going off like 7,000 calories, and I'm trying to avoid that. So what works best for me is to include some junk, like I just won the Super Bowl, and then cut it out after a couple days, and that system has worked for almost every test going back to 2015. So in terms of the junk that I consumed, on the first day, immediately after blood testing, I had some ice cream. More specifically, what we see there, Klondike Reese's ice cream bars. And note that on a second day, on a separate second cheat meal day, I had a double chocolate cookie ice cream sandwich from Buc-ee's. And man, it was delicious. So I don't know if anybody's been to a Buc-ee's, but that's an interesting road trip place to visit. And in terms of that cookie ice cream sandwich, it was one of the best I've ever had. It had me looking for Buc-ee's that were close to Austin so I could go for another cheat day, but they're too far. I'm not going to drive to the nearest Buc-ee's. It's just too far. I don't have that kind of energy to commute. On the same day after blood testing, I also had some cookies, and that's what we can see here. So it was the deluxe graham cookies, which are essentially chocolate covered cookies. Now, this was more for nostalgia. I had them as a kid. I probably hadn't had them in decades. So they were good, albeit not great. So I won't be revisiting them probably anytime soon. On the second day after blood testing, I had the standard chocolate mixed with peanut butter. So again, those chocolate chips, that's not 2 grams per day. That's not one little chocolate chip morsel every day for 56 days. That's about 70 grams on one day and then nothing on the other 55 days. On the third day after the blood test, I added about 30 grams of sugar to a homemade chocolate mix, so ground cacao beans mixed with dates, and I added that sugar. And that's it for the cheat meals. Those 3 days, Nothing else for the 53 days. So 53 days of clean, 3 days of junk. In terms of junk calories that correspond to test number 5, when adding the amounts in the ice cream, the cookies, the chocolate chips, and the sugar, I ate a total of about 2,500 calories from junk during this 56-day period. When divided by all of the calories that correspond to test number 5, it was 2%, about 2%, 1.9% of all calories. So in other words, that 16.5-year younger biological age is associated with a diet that was about 98% clean. All right, so this list is ranked in grams. What about ranking the foods in terms of calories? And that's what we'll see here. Top 10 foods for average daily calorie intake during that 56-day period from test number 4 to test number 5. And note that this list is generated by Cronometer. If you want to track your own diet with Cronometer, there's a discount link in the video's description. So atop the list now is sardines. Walnuts had been the top position for a couple tests, so now sardines are back at the top. And note that I'm not vegan, as clearly you can see, sardines being the number 1 food that I get in terms of calories on a daily basis. In terms of the remainder of the top 10, 6 of the top 10 foods that are shown here were also similar for test number 4. So I've said this many times in other videos, the goal isn't to blow up the whole system. At this point, it's to make small changes aimed at improving the biomarker weak spots without messing up the rest of the biomarkers. In terms of foods that entered the top 10, it was avocados, blueberries, flaxseed, and Brazil nuts, whereas oats, almonds, salmon, and peanuts left the top 10. All right, next up are macronutrients. What macronutrient composition corresponds to test number 5? So starting with average daily calorie intake, it was 2297 per day. Note that for test number 6, it was 2296 per day. The goal here wasn't just to have the same calorie intake, it's body weight maintenance, as body weight peaks around midlife and then declines thereafter, probably related to cancer cachexia. Protein intake, average daily protein intake for this test was about 96 grams per day, or 17% of total calories. What about fat intake? That's what's shown here. 99 grams per day, which is 39% of total calories. And note that that was a small increase relative to test number 4 of 91 grams per day. In terms of where that 8-gram fat increase came from, it was mostly from saturated fat, more specifically the coconut butter experiment, as the previous intake was 23 grams per day, and I increased that to about 30 grams per day of saturated fat. If you're interested in mono, omega-3, and omega-6 fats, those data are also shown there. All right, next up is carb intake. Total carbs, 296 grams per day, but note that net carbs equals total carbs minus fiber. Average fiber intake was 87 grams per day, and when we subtract that from total carbs, we get a net carbs of 212 grams per day. When multiplied by 4 calories per gram, we can see that net carbs were about 37% of all calories. Now note that fiber, a fraction of fiber, about 20%, is soluble fiber, which means that it's fermented by gut bacteria to short-chain fatty acids, more specifically acetate, propionate, and butyrate. And these are saturated fatty acids. So note that all saturated fatty acids are not the same. Coconut butter saturated fatty acids are not the same physiologically as short-chain fatty acids like acetate, propionate, and butyrate. When adding the amount of fat that came from soluble fiber fermentation, that adds about 175 calories, or 7.6% of the total diet. So now we can calculate net macros. In adding the 7.6% from fiber fermentation to the total fat amount, we get a total fat amount of 46.5% fat, about 37% net carbs, and 17% protein. Now note that within total carbs, I'm also tracking sugar intake, but sugars comprise a very broad group, including glucose, galactose, lactose, maltose, etc. More specifically, within sugars, I'm tracking total fructose intake because the diet is rich in fructose-containing fruits and vegetables. And that's potentially important because in my data, in the correlations, a relatively higher fructose intake is correlated with a lot more biomarkers moving in the wrong direction than right. So in terms of total fructose intake, it was 62.2 or 62 grams per day. Note that sucrose is half fructose. When you divide sucrose by 2 and add that to fructose, you get that total fructose intake of 62 grams per day. Now, I've mentioned that 62 grams per day seems like a lot, but my highest fructose intake that corresponds to any test since 2015 is almost double that, 122 grams per day. So this is progress, albeit not perfection. Next up is micronutrients, or micronutrients. Starting off with vitamins, and it may be hard to see, so I'd encourage going full screen if you haven't already. Now, without going through all of them, note that there is full RDA coverage for all of the vitamins that you see here. So for anyone starting on this journey, and I mention this in every video, I think it's an important point. For anyone trying to optimize biomarkers, I think the lowest level, the lowest hanging fruit is to make sure you're getting at least full RDA coverage for all vitamins and minerals. Now, maybe some, like riboflavin, should be higher. How high should you go? Well, in my case, many of the vitamins and minerals that you'll see here are purposefully higher than the RDA because I'm following their correlations with about 30 biomarkers. Now, some examples that I commonly cite in these videos would be, for example, vitamin K, which is about 23x the RDA, or vitamin C, which the RDA for vitamin C is only 60 milligrams. You can see for this test, it was 873 milligrams. And the only reason that these levels are so high is because, again, I'm following their correlations with a broad set of biomarkers that represent many organ systems. Now, for comparison, let's take a look at test number 4's vitamin intake. And without going through all of them, if you're interested in going through all of them, you'll have this data here to directly compare. But you can see that most of the vitamins listed here are consistent from test to test, or in the same ballpark. There are a couple of exceptions, though. For example, you can see riboflavin is far lower for this test relative to the test number 4. And again, I did that to get closer to a physiological dose relative to 243 milligrams per day, which is definitely not physiological. Again, we can only absorb about 30 milligrams per day, so 243 is essentially just golden urine. Also note that vitamin D, I cut that in approximately in half. We can see that there. And again, because I'm getting regular daily, 20 minutes of regular daily full body sun exposure. All right, next up are minerals. So I'm going to pull up both data for this test and test number 4. And we've got 3 minerals to highlight. First, selenium. So the Brazona experiment increased selenium to try to test that correlation with Candida IgG. I've started increased sodium intake for those who saw the sodium impact on norepinephrine, which may impact heart rate variability, resting heart rate, but also hair graying. And if you missed that video, it'll be in the right corner. I've slowly increased sodium intake. Actually, for test number 6, it's a bit higher, 2,500 milligrams per day. But for this test, we can see that the data started to move in the higher sodium direction. And then we can also see the effects of supplemental zinc. And without it for test number 4, as I've added that zinc glycinate 15 milligrams per day every day. All right, so that's the end of this video. The next test, test number 6, is scheduled for September 9th. So stay tuned for those data coming up in a future video. Rather than looking at dietary averages over a 56-day period, if you're interested in seeing the day-to-day diet, check us out on Patreon, where I post daily diet data and I post at least once per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, which I'm using every day, at-home metabolomics, we're up to test number 19. I posted that post yesterday on Patreon, so if you're interested in that, check it out. Oral microbiome composition, NAD testing with Ginfinity, I'm doing that at every test. Epigenetic testing with True Diagnostic. At-home blood testing with SciFox Health, which includes the best epigenetic clock of epigenetic clocks, GrimAge. Green tea, which I'm drinking every day. Diet tracking with Chronometer. Or if you'd like to support the channel, you can do that with the website, Buy Me a Coffee. We've also got merch, including Data is My North Star, which I've got on here. Figuring Stuff Out is my drug. And the ConquerAging or Die Trying channel logo. So if you're interested in wearing this merch, link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.